Hello and welcome to our video training series on the Agricultural Conservation Planning Framework. My name is Mark Tomer. I'm a research soil scientist at the USDA's National Laboratory for Agriculture and the Environment. I lead the development team for the ACPF. And the folks who are on that development team are David James, Sarah Porter, and Jesse Van Horn. And you'll hear a lot more from Jesse as you go through the video training series. So this is an effort to introduce a new technology into watershed planning for agricultural watersheds and encourage agricultural producers to more effectively participate in local watershed planning for water quality improvement. So we began work on the ACPF in 2011. This is something that's got essentially three pieces to it. There's a unifying concept for water quality management. It provides a consistent and scientifically defensible, but at the same time flexible approach to address water quality improvement in agricultural watersheds. The second piece is a database that brings together high-resolution data, which can be consistently applied in field-level conservation planning. And the third piece is an ArcGIS toolbox, the ACPF toolbox, and that can be used to propose possible locations for a variety of conservation practices. The practice placement tools can be tailored to the setting of the individual watershed, so it's very flexible. Locations are suggested showing options for placement of practices within fields, below field edges, and along streamside riparian zones. The USDA has a history of providing technical assistance for planning and implementation of conservation practices on farms, and that's been done in partnership with locally led conservation districts. This approach has been successful over a number of decades, and what we've done with the ACPF is aimed to build on that success at the small watershed scale by providing a consistent database of information and tools that help planners and farmers make technically sound conservation decisions for any given field within a watershed context, which considers landscape features upstream and downstream. So let's look at each of the ACPF's three components. The concept behind the ACPF provides a flexible approach to conservation planning. This is important because each farm and each watershed is unique. We believe that providing conservation options that are flexible and tailored to the local watershed facilitates producer engagement and will address water quality concerns associated with agricultural runoff. A variety of planning options with a mix of practices should always be identified to ensure that natural features of the landscape can be used to manage the detention and movement of water, and that landowner preferences are included as part of the planning process. The ACPF also emphasizes the critical linkage between soil and water resources and embraces practices that improve soil health, control soil erosion, and manage agricultural inputs to optimize their efficiency of use. So this conservation pyramid embodies the conceptual approach of the ACPF. Building soil health is the foundation, and practices that minimize soil erosion, manage nutrients efficiently, and increase soil organic matter are fundamental to successful management of agricultural watersheds. The ACPF does not target these practices to particular fields because any farmer should have access to USDA conservation programs aimed to enhance soil productivity and increase agricultural efficiency. However, every watershed landscape contains opportunities to control and filter water flows from farm fields. The location of these opportunities depends on soil and landscape attributes that are unique in each watershed. The ACPF toolbox is designed to identify these opportunities where water flow can be slowed for long enough to allow natural processes to improve water quality. The idea is to provide a treatment train or a sequence of opportunities for natural processes to occur across the landscape as water flows from fields to areas below fields and into the riparian zone. By carefully selecting from among the conservation opportunities that are naturally present in any landscape, this approach will be cost-effective and minimize the amount of land taken out of production. The second component of the ACPF is the ACPF database, which takes advantage of high-resolution spatial data and allows ACPF results to match the field scale, the scale at which conservation practices are actually implemented. Three types of core data are included, which are land use, soil survey, and elevation or terrain data. Our database assembles data for individual Huck 12 watersheds and utilizes a consistent structure so that the ACPF conservation planning tools can be applied in watershed improvement projects wherever the data are available. The land use component of the ACPF database consists of a history of agricultural crop cover data and detailed field boundaries. The USDA's National Agricultural Statistics Service has used satellite data and survey information to map major commodity crops nationwide since 2006. The results are known as the Cropland Data Layer and are publicly available. The ACPF builds upon these annual data by compiling a sequence of annual crop data, effectively mapping out crop rotations at the field level, which improves the utility of the data for conservation planning. Field boundaries offer the opportunity to examine the agricultural landscape at the level at which conservation practices are implemented. Our field boundaries are derived from an older version of the USDA field boundary database. In our database, these data have been edited to reflect crop-specific field boundaries. All programmatic data are removed to fully protect landowner privacy. So for each watershed in the ACPF database, land use data are assembled for the last 9 years, currently 2008 through 2016. These data are held in the crop history table, and for each field, the dominant crop is identified and its representative percentage of that field is calculated for each year. Using the last 6 years of land use data, we capture a variety of information that we can use to assign a crop rotation or general land use class for each individual field. The second type of data covered in the ACPF database is the soils information. We extract the soils data from the USDA's National Cooperative Soil Survey GSERGO database for each watershed. We extract over 40 different types of soil information, just a subset of the data available from the 70+ tables that are available in the original database. Different soil properties and their distribution on the landscape affect the mix of practices that can be implemented for any given watershed. And the final core element in the ACPF database is the elevation or terrain data. This is the most important component of the database because these are the data that tell us how water flows across the land surface. Most of the conservation practices that we work with in the ACPF address water flow on the land surface. An accurate representation of the land surface and its hydrology is critical for conservation planning at the small watershed scale. The high-resolution elevation data are typically derived from light detection and ranging or LiDAR surveys. LiDAR data provide the detail that we need to capture the nuance of the landscape necessary for identifying specific locations for individual conservation practices. These high-resolution data enable detailed assessments of critical terrain attributes such as slope and concentrated flow to understand how water moves across the land surface. This allows us to identify appropriate conservation practices that are designed to interrupt water flow, enabling sediment and nutrient losses to be trapped and treated. The ACPF Toolbox is the third component of the ACPF, and it provides a variety of watershed planning tools that operate under ArcGIS. These tools are designed to edit and process the terrain data and to identify locations suited for a variety of conservation practices. Here I'm going to zoom in on the listing of the tools so you can see some of the names of the programs a little more easily. In the next few slides, I'll be providing some examples of the kind of practices that are mapped by this software. Just keep in mind that when we're doing this, we're identifying opportunities for placing practices on the landscape and developing a set of planning options, but we're not developing a planning prescription. Recommendations for actual implementation should be developed considering the results of these ACPF tools, but also producer preferences and in the context of locally led watershed planning efforts. So let's take a look at a few examples. In the next few slides, we're going to show you some of the practices that can be cited or proposed using the ACPF software. In each example, you'll see a photograph of what the practice looks like on the ground and a map of what the results look like as they come out of the ACPF program. So the first example here is the grass waterway on sloping cropland. Concentrated water flows can often occur, and in these areas this can lead to the formation of gullies, and grass waterways are planted along these flow paths to keep the soil in place and prevent gullying from occurring. Contour buffer strips are another practice that could be cited using the ACPF toolbox. Contour buffer strips are also strips of grassy vegetation placed in sloping fields, but these are placed along the topographic contour to intercept sheet and rill runoff that occur above areas of concentrated flow. The spacing between the strips can be adjusted according to slope to closely match the spacing to NRCS design specifications. So the next practice we're going to show you is water and sediment control basins, or WSCOBs. And so these are shallow basins placed in fields that detain runoff water for just long enough for sediment to settle out, and this can improve water quality without impeding farm operations because the time of ponding is very brief. These can be placed, and typically are placed, in a sequence in a field, as you can see in this example. But there are also options in the ACPF that allow suggested practices that treat more land to be prioritized at the option of local planners. So the three practices I've shown you so far are designed to address surface runoff and the sediment and phosphorus loads that are conveyed by surface runoff. But subsurface flows are also important, and this is especially true in the Midwest, where artificial drainage systems have been widely installed. Tile drainage systems are comprised of networks of perforated pipes installed in farm fields to lower the water table and enable farming to take place. There is a separate set of conservation practices that are used to manage tile drainage and reduce nutrient loads. One of these practices is controlled drainage. This is used on flat fields to change the water table depth at different times of the year. So this practice is also sometimes called water table management, and it can reduce the volume of drainage and therefore nitrogen loads as well. So the second practice I'm going to show you that addresses tile drainage is the nutrient removal wetland. So these are formed by placing low impoundments along ditches and streams and drainage ways located below several tile drain fields. And what we do with the ACPF is to locate these wetlands and check that their size is appropriate to treat the drainage area while not impeding free drainage from these fields that contribute into the wetland. So tile drainage water typically flows through a pipe and is outlet directly to a ditch or stream. And in the past, riparian buffers placed along these ditches or stream could not interact with and treat the tile drainage water. So we have a new practice now called the saturated buffer that can be used in this situation. Tile flows are diverted and discharged into the riparian soils, which become saturated so that natural soil processes can act to remove the nutrients from the water. But not every streamside environment is suited to the practice because risks of crop inundation and bank sloughing do occur. The ACPF saturated buffer tool highlights locations where the risks of these unintended consequences are minimized and where soil conditions are well suited to treat the drainage water. So I've shown you examples of 6 different types of conservation practices. Combining the output from a number of ACPF tools provides not a planning prescription, but a unique menu of opportunities that can be evaluated and vetted at the local level. So think of this as a buffet. There are many opportunities in a buffet to expand one's taste for conservation, but no one is forced to try everything that's on offer. As you can see on this map, essentially every field in this watershed has some unique opportunities to contribute to better watershed health. So how do you actually use this information? Here's a picture of a couple of the landowners in this Indiana watershed viewing the same map. One of the local district staff is reviewing the results with them. You have to allow people time to consider the opportunities that new technologies present. The ACPF technology provides a set of ideas for discussion, review, and revision that helps local decisions ensure that conservation benefits can be extended downstream. Discussions about conservation opportunities identified by ACPF results begin with what could be done, not what should be done. The ACPF has been trialed with landowners in several watersheds, and these early case studies have been reviewed. And as that's occurred, we've learned that there's a variety of approaches for using ACPF results to engage local producers. So I have a number of people to thank who've acted as partners in this in the process of developing this and making the ACPF available. Our website is hosted through the North Central Region Water Network. which is housed at the University of Wisconsin Extension Service. Thanks to Rebecca Power there. At the University of Minnesota and the Water Resources Research Center there, they provided a lot of advice on the uptake of the ACPF and towards the development of these training videos as well. So thanks to Ann Lewandowski there. And at Purdue University, Linda Prokopi and her postdoc there, Pranay Ranjan, have conducted studies of case examples where ACPF results have been used in watershed planning, and we're grateful for the work that they've done to kind of assemble the lessons learned from the use of the ACPF. Support for the ACPF development has been provided by the Natural Resources Conservation Service, and thanks to the folks at the Central National Technology Center in Fort Worth there. And the ACPF actually began under an NRCS Conservation Innovation Grant that was headed by the Environmental Defense Fund and Eileen McClellan there. So enjoy the rest of the training videos, and let us know any feedback that you may have. Thank you.